Okay. Welcome, everybody. It's great to be here at DevVox again. Last year was my first DevVox, and definitely one of my favorite conferences ever. It's pretty awesome. So I'm David Blevins, and I'll be presenting the changes that we did in EJB 3.2. Before we get started, so who is using EJB? I'm assuming the majority of the room? Okay. Great. So interesting, who started using EJB after 3.0? Okay, so we got a lot of old school EJB fans here, so that's pretty great. Yeah, so I've been involved in the EJB specification since EJB 3.0. I was heavily involved in EJB before that, was one of the founders of the Apache OpenEJB project, which we launched off in, way back in 1999. And it's still there, and it's part of the TomEE application server, Geronimo, and so it's out there. We're pretty happy with it. So yeah, as I mentioned, I've been part of EJB since 3.0, EJB 3.1. The embedded EJB container API was one of our contributions. We're really proud of that one, and as well, the EJB in wars concept kind of came out of there as well. So. An overview of what we're going to discuss in this talk. So there weren't a lot of changes in EJB 3.2. It was sort of a quiet spec revision. There was one change that you should not miss, and we'll be focusing on that quite a bit. But I do want to go over some of the small changes that were there because they do have some impact on you. And as well, really the more interesting thing is what's going to happen to EJB in JavaEE 8. There'll be some big changes to it in that specification. So first, the logical changes. So really big win is now entity beans are officially deprecated. So they're dropped from the spec as a requirement for TCK compliance. For your certified server no longer has to have CMP or BMP entity support if they do not choose to have it. They call this being made optional. It's the fancy way of saying at the spec level it's being deprecated. So as a little hint to yourself, if you want to break up with your spouse or your wife, or you're going to say you're being deprecated or you're being made optional. Yeah, that horrible joke. Anyway, so JAX RPC is also being made optional. And that was quickly deprecated by JAX WS. And then now these days, a lot of people are using JAX RS instead of JAX WS, but they're both pretty relevant, and they're in the full platform, but now are optional in JavaEE 7. Anybody using CMP entity beans? Okay, troopers. Who's using them by choice? All right, we got one. Okay. Yeah, so these features were moved to a separate section of the specification, and that drops the EJB specification down a whopping 225 pages. So that's a pretty good win for everybody. It's a lot, not quite as big as it used to be. So that's a very nice change. Another thing we did, which was lift some of the picky restrictions that were there in the EJB specification. So one of the things that it had said from the very beginning was you can't touch the file system. And that made no sense at all. People do it all the time. It's a natural thing. And what that led people to think is, if I'm in an EJB, I can't use files, so I have to use a servlet for that instead. And that was missing the point. The intention was that anything running in the server in a multi-user environment could have some issues if you start touching files. If two threads come in, they hit the same file, you might have some problems. So it should have been just a warning, not a restriction, and it should have been at the JavaEE spec, not in the EJB spec. The reason it was there is really just legacy. EJB was sort of the center of the JavaEE platform, so that a lot of these types of ideas got put in EJB, but they really applied to everything. So that now is simply a recommendation to be cautious when using the file system. It is not something it is no longer a restriction that you're not allowed to do it. So that's a very nice one because people say that all the time. I can't use EJBs because I have to use the file system. It's totally natural. Another one is API groups were added, and this was really more because certain things are being made optional, and so now we have to have some work to group them up. So this is more for vendors, and for you when you need to use your server, you should ask them if you need any of these features. Do you support, if you need the CMP Entity Beans, for example, do you support the Entity Beans group? And if they do, then it means they will have had to have run the respective tests for that and have made it completely compliant before they let you use it. And so if you need any of these things, you should ask the people, if you have a JavaEE server, you should ask them what things that they support. Because it used to be all or nothing. You support EJB or you don't. But now it's being sort of dissected up in efforts to make it more modular, a little more easy to digest. So keep in mind API groups when you start to shop around for your JavaEE 7 server. Okay, so we removed some annoying things and fixed a few issues in EJB. So business interfaces, there was a small bug in there, or a really annoying one, where things worked for a while, but if you added certain interfaces, they would suddenly break. So if you had code like this, you've got your local interface is implied to be red. This was something that was added back in EJB 3.0. So if you did this now that code would break. It wouldn't deploy because the rules were sort of obtusely stated because EJB supports both remote and local types of interfaces. It was thought to be too confusing that this would work, and so it was made it was required to not deploy. It was required to be illegal. And so what you had to do is you had to do this in order to make it work. Or you had to annotate each of those interfaces individually so that they had @local on them, or if they were using remote, it would have to be @remote. And so we fixed that, and now what was an illegal thing is now completely fine and works. This is a nice little small one. Another thing that we fixed is interceptors. So there was a problem with interceptors where if you were using around invoke, you were allowed to return object and throw exception, but all around advice for, say, your callbacks, post construct, so on and so forth, weren't allowed to return object and weren't allowed to throw exception. And this led to some very, very, very weird code. The logic behind that was, well, callbacks have all callbacks like post construct and pre-passivate and post activate, or pre-patent, whatever, they all return void and are not allowed to throw exceptions, so therefore the things that intercept them shouldn't be allowed to throw exceptions either. But it made it so you had to do code like this. If you wanted to intercept the construction of a bean and maybe do some other things with it, you actually had to catch the exception because the proceed method there throws exception, and then so you have to now catch the exception, and then maybe the best logical thing to do would be a wrap it in a runtime exception, and this was just really, really annoying. If you had 12 interceptors, they would all have to do the same thing. So basically, if a runtime exception did get thrown from your bean code, it would be wrapped 12 times by the time it reaches the container. It was broken. And then the other problem is that you had to now duplicate your interception code. If you wanted to do something simple like track how long method invocations take and do this across all the beans, all the method invocations, including the callbacks, you would have to have one set of intercept logic and another set that didn't. So you weren't allowed to return objects, so you couldn't do this. You couldn't have post construct and around invoke because it would be seen as breaking the spec because your post-construct interceptor wouldn't be allowed to return object. So we fixed this now, so you are allowed to use the same method signature for all your interception, and now you can actually, with one method, intercept everything that will hit the bean, which is a very nice little change. This is one of the ones that I particularly found annoying when I went to write some statistic monitoring code for our container, and then I realized, what do you mean I have to have 2 methods? That doesn't make any sense at all. So that's something we fixed post-haste. Transactional callbacks. We added singleton beans in EJB 3.1, and we made it possible for singleton beans to have transactions when they're constructed. And this was really useful because if people wanted to use a singleton bean to, say, initialize some state in the database, that was really great. And they were allowed to do that with their server startup event that you might get with a singleton bean. But the problem was we didn't extend that to any other part of the EJB spec. So stateful beans, for example, were not allowed to have transactions when they start. So their post-construct method is invoked in EJB 3.1 in prior container without any transaction at all. So you cannot use things like entity managers. It's a very small, very annoying limitation. So if you wanted to actually do something in the construct method of your stateful bean against the database, it wouldn't have worked. Now it's possible, and you're allowed to use the requires new transaction attribute. Okay, this one is really along the lines of lining up EJB with CDI, which is going to be an increasing thing that we do in JavaEE, in JavaEE 8. And I'll be talking about that towards the tail end if there's time, which I suspect there will be. So before EJB 3.2, passivation was sort of implied on stateful session beans. This may happen, it may not happen, and you as developers didn't have any control over if it was going to happen at all or when. Well, you still don't have control over when, but at least you have control now of if it's going to happen at all. So you do not have to design your stateful session beans to be serializable if you do not want to be. Where this comes in is CDI, and first let me ask the question, who has dug into CDI at all? Pretty good amount of hands. That looks about a fourth of the room. I encourage the other 3/4 to really take a look at it. You'll see why towards the end of this presentations. EJB and CDI are effectively very similar technologies. And so what was there in EJB is so we have the stateful session bean concept, and in CDI you have something called scopes. So basically in CDI, all instances are managed in, say, like a map, if you will, to be very simple. And so the duration that map lives is dependent upon what scope it is in CDI. So for example, there's @session scoped, and that means that anything in the @session scope will live for the duration of the HTTP session. And when the session is destroyed, everything in that map will be destroyed. And so some scopes in CDI are passivation aware. Basically, they can be clustered. So anything that's in session scope, for example, can be clustered. Now, there are other scopes in CDI, for example, request scoped, that are not. And request scope is a very short, limited scope, and anything you might use a thread local for, you could replace with CDI request scoped. And basically, everything in that map will live when the invocation starts, and all the objects will be created dependency injection style, and when the invocation ends, everything in that map is destroyed. Now, there is never going to be passivation. There's never going to be serialization. That's not something you can cluster. It's simply one effectively stateless call. But the problem was that if you wanted to have a stateful session being involved in this, everything it touched would have to be serializable, and that would put crazy restrictions upon your code. So that was lifted, and this was fixed. So now you can do like this, and everything is fine. This will guarantee that the container will never try and serialize your stateful session bean to disk. Okay. Another small change was the timer service in general was very bean-centric. So there was no way for you to query your application to see how many timers you had across the entire app. Now there was a method there called getTimers, which would allow you to see which timers applied to that specific bean, but there was no way for you to, in general, query about what timers existed globally, or at least at the module scope. So that was changed as well. there was some non-specific language about whether the timer service objects, such as timer and timer handle, would be usable outside of the EJB itself. We've clarified that and said, in fact, they are usable. Another one, this is actually a very nice change if you happen to use EJB Security, which seems to be a rare thing. Let's ask that question. Who uses EJB Security? Far fewer hands, yeah. It's maybe 10%, which I didn't even think we would get 10%. But that's probably something that we'll be fixing up in EE8. I hope, knock on wood, if there's some right in front of me. So in EJB Security before, you had to specifically list the roles, and there was no way to simply say, I don't care what their name is or what role they have, I just want them to be authenticated. So there was no way to draw that line. So that was added in EJB 3.2 with the implicit ** role. So if you use ***, that implies any authenticated user, which is nice. In the previous moment, there was no way to do this. Also, there was a little bit of a heavy requirement, and the 10% of the room that do use EJB Security will be happy to hear this. You had to declare all your roles in the XML file, and that was a really big pain in the butt. So now we've said that if you use @RolesAllowed and you list manager as a role, we're all pretty good at figuring out that you probably meant you wanted a manager in your XML file, and you don't need to go update that. So that's a very nice addition, nice little change. Okay, so this slide is misplaced. Okay, let's let's go on to the next one. So here's where we have a bigger change. So MDBs. How many people use MDBs? Okay. I gave a talk last year about that involved MDBs. Who happened to see that talk? Okay, great. So I won't be boring too many people to death by going over the same material. All right, so big surprise, MDBs are not JMS specific. Blowing a lot of people's minds, I'm sure, because it was never publicized. So here's the story. Here's what happened. In EJB 2.0, MDBs came out, and of course they were JMS specific. But then a lot of questions started to get arise on how to portably plug in a JMS provider and get transactions and security to work. And so then the connector architecture got expanded to have something called inbound connectors, and MDBs effectively got, at that moment, EJB 2.1 got decoupled from MDBs. So you could actually power an MDB via any connector that you wanted to write. And very few people even knew that this was possible because it wasn't really widely publicized and no one bothered to shout it from the rooftops. And so it just went unnoticed for really the last, gosh, how long has EJB 2.1 been out? 8+ years at least. And so there was so much potential there, though. It deserves some attention. And so here's the problems with MDBs. So knowing that you can connect in anything you want with an MDB, and by the way, MDBs don't have to be asynchronous. They could be synchronous. You could have an HTTP connector for an MDB if you wanted, and drive. Say you're using WebSphere for your server, and you wanted to plug in Jetty. You could use a connector to plug it in and use that to have beans that consume Jetty-specific HTTP content. All right, so here's the problems with connectors, with MDBs. So the interface between the MDB and the connector is defined in this configuration. So it's very outdated. When we created EJB 3.0, we missed an opportunity to improve this API significantly. So here's the first problem with MDB configuration. So one, you don't know how many properties are supported by your resource provider, which in most cases, JMS. So you don't know what options you have. So you have to go Googling around for all the various configuration parameters that are possible that you could put in your activation config. There's no way for you to know them up front. Secondly, everything is loosely typed, strings everywhere. I mean, effectively, we have a properties file at the top of our class that defines what options you would like to use. But you also not only have to read the documentation to figure out what properties are available to your application from your JMS provider, but you don't even know what type they are. And if you use the wrong type, it's all strings. This is all parsed. Your IDE cannot help you with any of this stuff. This is a really big problem. The second thing is the metadata is effectively only allowed to be configured at the class level. And this is not modern. This is not the way we're designing APIs these days. So what this led, if you were to have an MDB, if you have a connector that you wrote, you would really only be able to probably provide one big method, because you only were allowed to specify metadata on the class level. Another one is that you had to have a message listener interface with a specific set of methods. So the vendor, the person who creates the connector, makes the interface, and then you implement it. But that's not the way we're designing APIs these days. This is actually pretty outdated. This is really just like the servlet service method. And so in order to have something that's one size fits all, you end up with one big method, and there's some lessons to be learned here. So what opened up our eyes really is JAX-RS. So if you look at JAX-RS, they really cracked the nut on how good APIs should be developed. Okay, so before in the HTTP world, we're having servlets with the big service method or the big post, or do get, and we're doing all this shuffling around of pulling things in and out of headers, and we're casting, and we're taking parse int, and we're taking strings, and we're parsing integers, and we're doing all this crazy stuff that we really just don't need to do anymore with now that JAX-RS is there. But with an MDB, we're still doing that kind of thing. We have one big method that consumes message, and then you've got to cast it, and you've got to pull all the data out, and you're doing all this shuffling, where JAX-RS showed us a couple years ago, how to do an API like that really, really well. But the problem is that JMS, the connector API did not allow for annotations to be exposed to the connector provider. So if you as a Bean developer were to annotate your Bean with all these things and want to have a nice API, that was not something that we could expose. So as I mentioned, this is the only bit of information that the JMS provider gets. Effectively, they get a hash map, and they have to do all the parsing of it, just like you would from a servlet request or something like that. It's limited. So this is so 2004. This is what we want. So if you look at this, previously we were saying max sessions is a string, its property value is 3, and now we would like to say instead at max sessions and pass in a strongly typed data, the numeric value of 3. And if you put in a string THREE, your compiler is not going to let you do that, and so you have strongly typed stuff. And so here's what this would fix. Now things would be strongly typed and self-documented. Big wins. So now when you look at your JMS provider's options, you can just go to their Java doc and you can see all the annotations that they would support. Huge win. You would know what their values are. They can be documented quite easily. And then the other thing is it fixed targeted configuration. So whereas before you were only ever allowed to have the fixed methods that the JMS provider decided that you were going to have, in this case, message listener interface, now it's possible for you to have basically any number of methods that you design JAX-RS style, and then the JMS provider would just basically figure out what you mean, just exactly how JAX-RS works. And so you would be able to put metadata on those methods, and then that would get you maybe one message-driven bean that allows you to consume everything that you want to pull off the topic or the queue or the entire thing, rather than having one MDB per per topic and one for the queue. You could have as many of them as you wanted. There's nothing stopping that now. Basically, that part's busted wide open. So the fluid method signatures is what we would get out of this. So if you don't want to consume, say for example, you're consuming object message, what's the very first thing you've got to do in your code? You've got to take and implement message on message and your message listening interface. You accept message. You got to cast it to object message. Then you've got to pull the object out of the message, and then you got to do something with it. And so, you know, it takes a lot of work. So, victory. All right. Well, the caveat of it. Oh, we have a question from Jason here. Yeah, so I'll show you how you build a connector, and that will be covered in that part. But yeah, so this is a futuristic view of JMS. So here's the catch, is that we fixed this underlying plumbing to allow this stuff to happen, but it happened pretty late in the specification. So therefore, the JMS group was not able to leverage it quite yet. In fact, this feature almost never got in. It was done at the very tail end of the specification. In fact, I presented this idea last year at DevOps, and so actually that was a very big push that got it into the spec. So I challenged everybody to let their voices be heard and go to the EJB spec group and upvote the JIRA where this idea was, and we did. We got about 30-some votes. And it was, pretty great. As well, I went and implemented this in Glassfish just to so that it was clear. There was no time left in the timeline of the specification to get it in. So I was like, all right, it's a competing server, but the idea is better. So let's roll up our sleeves and make it happen. So that was really a community-driven feature. It's one of the better stories of community activity in the JavaEE specification. But yeah, like I say, JMS, the next version of JMS, the spec lead is completely committed to having a very nice annotation-driven API like this. It might not be these exact annotations, but there will definitely be something there. And if this kind of idea excites you, I really encourage you to get involved in the JMS spec. They are first of all, who knew that the JCP was now a public affair? Good. We got like maybe 7% or something room. So here's what happened at the spec level. JavaEE and all this types of things were developed in a closed forum for many, many years, and it was invite only. Then in the last round of JavaEE 7, after JavaEE 6, there was a change made in the JCP. So basically, after Oracle purchased Sun, they busted the doors open. So every specification has to have a public mailing list, has to have an issue tracker, and you as developers are required, they're required to give you full access to that JIRA, to everything. So you have the ability to go, you know what, I don't think this is right, let's add this idea, or let's change this idea, or let's completely redo something. That is a power that you now possess, and I really encourage people to use it. There were a few people in EJB 3.2 that did pop up who've been EJB users for a very long time and had a laundry list of things that they wanted to fix, and they did get some ideas into the specification. So if you have a laundry list of things that you'd like to see fixed, go directly to the specification. I'll show you, the links that you would need to do that at the end of the talk. All right, so even though JMS is not leveraging this yet, hope is not lost. The power is in your hands to do whatever you need to do with the connector architecture. So you now have the ability, as you did before but weren't aware, to plug anything into your server and accept incoming requests. In a connector, you can do things that were historically been forbidden. In a connector, you can launch off threads. You can open sockets. You can accept incoming communication. You can take that package up any way you want, and then you can invoke a bean in the server. There's an API for doing this. It's very, very simple. So with this, you could do all sorts of things. Creativity is the limit for this feature, literally. The feature is as powerful as you want to make it. So some of the very obvious ideas that would be great connectors, an email connector. If you wanted to consume email messages in your JavaEE server, in the cloud, write yourself an email connector, deploy that in your server, then now you can send yourself email messages. If you wanted to take and wrap up Jabber, for example, grab one of the Java libraries for Java for chatting, Jabber, and then you can wrap that up and expose that as a deploy that into your server as a connector, and it can basically listen for people sending you messages and then communicate that data into some component of your choosing. SSH, Stomp, Thrift, basically any protocol that you would want to consume, you could now write a connector to do that. It's actually been very, very shocking to me that we haven't just demanded this. We push everything over HTTP all the time because that seems to be the only way we can get data into our servers. But there are all sorts of really great protocols, and I think the nice thing about existing protocols is they have clients. They have really nice clients, like if you wanted to send data to your server via Apple Mail, you could do that. Simply you're missing the connector on the server side that would accept and listen for that communication and push it into your server. So you would be able to write your own JAX-RS. JAX-RS itself could have been created as a connector had we fixed the connector architecture earlier. And now those types of things can be made connectors. And what I hope to see is people independently writing connectors, open sourcing them, and a nice little library of common adapters that people can deploy into their servers be created. That would be really fantastic. That would all really, really derive some value into what we do in application servers. Right now, we sort of tend to avoid application servers when we need to do non-traditional things. There's no reason to avoid them. So writing a connector is really, really easy. You just need 4 things, okay? So 1, you have to create a message listener interface, which answers Jason's question earlier. The message listener interface does not have to have methods in it. In fact, if it has methods, it should not have any methods in it. If you want to have this modern style MDB. So create yourself an interface. It's just there for demarking purposes. In the next version of EJB, we will try to eliminate the need for that interface. It's there for legacy purposes. The interface tells the container which connector to use for that MDB. So that's why you need the message listener interface. It was too late to do such a deep change to the connector architecture to make that tiny little interface unneeded. So without, it doesn't have to have anything in it, but then you need to have an activation spec bean class. It's just basically a Java bean, has to implement one specific interface, doesn't need to do anything either. So these are 2 legacy things that you just have to put up with. But then you implement the resource adapter interface, that's where the meat goes, and then you wrap it all up in a resource XML file, an RA file. So here's a nice little demo of how that works. A nice little demo of how that works. And is that visible to everybody? Maybe I should increase the font a bit. Okay, we don't want that directory. Okay, so here are the 3 technical things that you have to create. The meat, I'll go straight to the meat. No, I do not want to add that. And we'll increase the font on this. Great. Okay. All right. So the first thing you do is you implement resource adapter. Okay. There are very few methods in here that you have to worry about. Basically, the resource adapter is the thing that will be actually doing the driving, accepting the messages and the communication, and then invoking the bean itself. So here's how this works. You implement resource adapter. It's got a start and stop method. This happens on server startup and server shutdown, or on the deploy of the application if the resource adapter is inside the application. Very, very intuitive. Here's slightly less intuitive. Endpoint activation and endpoint deactivation effectively are deploy and undeploy. So don't let their confusing name, don't let their name confuse you. So that's basically deploy and undeploy. Those are really the 4 methods you need to worry about. And so this one down here that says get XA resources, it is possible for you to use transactions and include what you do in the connector as part of transactions. If you do not want transaction support, just return that, an empty array, and that basically says we don't support transactions in this connector. Okay, so it's called endpoint activation because basically your MDB in the message in the connector spec, the MDB is not called an MDB, it's called an endpoint. So be aware of that. It's always great to confuse people. It's what spec leads are born to do, create complexity around simple concepts. That's an unfair assessment, but it tends to work out that way. You get paid by the word when you write specifications, it seems. So endpoint is effectively the MDB. It's your bean. And so here what we have is we have a message endpoint factory. Basically, that is an MDB factory. That is something that will allow you to create instances of the bean. And so what we're doing here is we're calling create endpoint, and we're casting that to the message listener interface that we've created. So let's take a look at our API just real quickly. So this example here that I'm showing is a sort of a telnet idea of a connector. So we have our message listener interface, and it just, like I said, no methods. And then we have a bunch of annotations that we will use. And we have an MDB that would use them like this. So here we have message-driven. That's what you need to have to specify that this is an MDB. We implement the message listener interface. And then we have annotations that are created by the connector, and then we use as the developer. And then we can do fun things. And this is, like I say, this is just a little small connector that I hacked up in like a weekend. And it's not hard to write these connectors. It's really more fun than anything because who doesn't like to be an API designer? Who doesn't like to write APIs for other people to use? It's kind of one of the greater pleasures of coding, writing code for somebody else to use. It's great. And so, very JAX-RS inspired, as you can see. We have parameters that are annotated, and that allows us to generate things like the help and stuff like that. Anyway, so it's very, very simple. So what we're doing in our resource adapter is we're saying, create me an instance of this bean. We cast it to that interface. And what this will be is effectively, you know, in EJB, you can get a reference to a bean that has no interface via @localbean. Effectively, this is a local bean proxy. You should think of it that way. What you get as a return value of this is basically a local bean proxy. It will have all the methods of the bean, and you can invoke them in any order you want, under any conditions you want. You're the connector. You have complete control. So that bean on the other side will be, you know, like a stateless bean or so on and so forth. It will have full dependency injection done on it. You can have CDI wired in. You can do all the things that you can do as an EJB, and it's right there for the taking. So we're just going to, in this one, we wrap the object, and then we call activate, and then, so basically you're required to call before delivery, after delivery, and release on your MDB endpoint, on your message endpoint. Before you deliver a message, before you invoke it, you have to call before delivery. When you're done invoking it, you got to call after delivery, and then when you want it to be destroyed, you call release. So real simple. That's the entirety of the API. It does not take a long time to write. So I will run this and show you how this works. So I've got, this is not exactly a unit test, but I used Archillion to wire up the application just so you can see all the parts. Who has used Archillion? Good. The ones of you who didn't, second recommendation for you, go check that out immediately. And the Archillion guys are here this week, so we got Aslak and Dan and a bunch of other guys, so please go ahead and get in touch with them and ask. It's a wonderful testing framework. But I'm using it here just to basically wire up my connector, create an EAR file with it, and deploy it into the server, and then create a web app that uses a little application that hasn't my MDB in it. So I'm going to run this. Okay, so this is actually running using TomEE. That's already booted. So it says down here, listening on port 2020. So now I can, let's increase the font just a bit here. Telnet localhost 2020. And now I've just logged into my JavaEE server via a Telnet client. Oh, I didn't, okay. There we go. I didn't have the ls in there. I'll have so here are the commands that I've got, and you know, I can say set foo to bar, and then if I say list, it lists. I basically have my MDB. It's got a properties object in it, and when I say set, I throw things in the properties object, and when I say get, I get things out of the properties object, and when I say list, I list things from the properties object, just to show you that you can actually have state. It doesn't have to be asynchronous. It can be very communicative. You can have actually state involved in MDBs, and you can carry a session. In fact, I started to work on another version of this that would use a CDI scope that would start when the Telnet session started, and then you could put data in the CDI scope, and then any user who's logged into your server would basically have their own scope, effectively giving you something like an HTTP session, but are now all Telnet driven. The sky is the limit on what you can do. Like I say, creativity is the only obstacle and the only limitation here. The doors for you extending the server have been busted wide open. And this is all very dynamic, right? So as before, you had to basically just use the methods that were in the message listener interface that the connector decided to give you. Now there's a possibility for the connector people, I hope you become connector creators, to give more fluent APIs to people that allow them to decide what they want to consume. Like I say, very JAX-RS style. So if we go over to the MDB here, and let's add that at command. First of all, let's shut the server down so I don't try and redeploy over the top of myself, because I will forget. All right. Since I don't have actually implemented that, then I will just put some ad hoc things in there. So we'll run this. Yeah. No, I just use that as a convention. You know, in my connector, basically, I take a look at the bean class, I iterate over the methods, and the ones that have at command, I just put them in a map. And then when a request comes in and I see someone type ls, or for example, on the shell, then I go find the right method to invoke, and I parse the arguments and I invoke it. Yeah, it's part of the connector that I created. So I created a little telnet connector, put this at command in it, and all the API you're seeing is of, you know, effectively, when I say my creation, I mean, you know, you as the people writing the connectors can write the API that you want your developers to use for hooking and consuming data from your internal systems. So really, what I've noticed over the, you know, n number of years is that people who have legacy systems tend to have a server that will you know, still consume data from this legacy server. Then they batch it up and they post it over via REST or something like that. And there's no need to do that shuffling anymore. You can, if you wrote yourself a connector, you could have that data consumed directly by the server. And the cool thing is like if we deployed this, say, like on Jelastic or CloudBees or Heroku or something like that, I would be able to telnet into my server in the cloud. How cool is that? And if you want, there are good SSH Java clients. You could write yourself an SSH adapter and SSH into your Java process, not the VM that Java is running, the actual Java process. So if you wanted to expose some manageability for yourself, pow, you've got some huge potential here. No need to use JMX or anything like that anymore. You could actually just go ahead and interactively see the inside of your server from the outside if you wanted to write a connector to make that happen. All sorts of possibilities here. It doesn't have to be a command line based thing. There we go. So now I just added that method and it said list what exactly. So it's very cool. Very, very cool. Your opportunity to be an app server developer. Pretty cool. I mean, before it was always just wait and we'll create an API for that, and then we'll decide when we want to release the next version of JavaEE, and then you'll get it. So I hope you've got some time to kill for the next 3 years because it will be a while. Those days are over. Now you can write very big extensions to any server, deploy them in any server portably, and never have to wait for another big spec revision. So the next group of people who want to create the next JAX-RS don't have to wait a day. If you want to be on the forefront of creating the next cool API for JavaEE, door is open. It's very, very nice. Yes, yes, it is on GitHub. Yes, yes, it is on GitHub. So there we go. And so this project is actually, if you go look at it, there's got 2 folders, MDB today and MDB tomorrow. That's what I presented at DevOps last year. So understand that MDB tomorrow is now MDB today because the feature got in. And so do the mental shifting around, and you can feel free to ignore the MDB today section. It will look crufty and old. And then as well, I started a little GitHub project called JCA Quick Start. And the idea of that is just, I mean, like, because there's so very little information about connectors out there, to provide at least some little place where people could contribute whatever they find in terms of documentation or learning, or if you create yourself a little connector and it's available on GitHub, go ahead to go to the JCA Quick Start and update the documentation with a link to your project. So that way there's at least some central place where we can get some information. I hope that the connector spec itself will eventually become the center, but until then, I hope that we can fill the gap with this. Okay, so first of all, let me just go to this next one, and then we'll go with questions. So now, that's up to now. That's JavaEE 7. So JavaEE 8. The future of EJB is really going to be about lining up EJB and CDI in very significant ways. So this section of the presentation is really to help you understand what that means and why. So you can participate in the conversation, because as I mentioned, everybody should be involved in curating and giving feedback to the technology they use. I'm a strong believer in that kind of thing. So first of all, understand that EJBs are effectively CDI beans. EJBs can have all sorts of scopes. So stateful session beans can be request scoped and things like that. As well, they can consume events, interceptors, and decorators. They can do anything a CDI bean can do, you can do with an EJB. So understand that they are already in some way aligned. What we're talking about here is the ability to do certain things that EJBs can do in a CDI bean that isn't also an EJB. So if you had a CDI bean and you did not want it to be an EJB because you didn't want it to be, say, stateful, singleton, or stateless, you didn't want to pick between one of those, you want to just have a pure bean, you can do that. But really, under the covers, EJB and CDI are like, brothers from the same mother. They're the same technology, practically. And so one thing, too, for those who don't understand CDI is, as I mentioned, who have never really used CDI, the way CDI and EJB differ is how instances are managed in CDI. It's much more flexible than EJB, which is why CDI is pretty much going to be the thing that replaces EJB. So here's how to understand them at the high level. This is a good slide to take a picture of because it's good for future reference. So the top there, we have a proxy, right? So EJB, when you have a reference to an EJB, it's not the actual bean that you have a reference to, it's a fake. So when you get something injected into your component via @EJB, and you have a field of, say, private red or private green, what the container gives you is a stub. It's a fake. It's a stand-in. And every time you invoke a method on that, what the container does is, one, it finds the actual bean that needs to be invoked. In the case of a stateless session bean, obviously it pulls an instance out of a pool. And for singleton, the bean is sitting right there, ready to be used, or it's instantiated lazily. And then we have what we call services. So now that the container has the bean itself, the container will enact all of the services required before invoking that method. So this is how your transaction support happens. It will start transactions. It will do things like that. This is where security comes in. And then it will invoke all the decorators, all the interceptors, and then eventually the bean, and then the return value comes out, transactions are stopped, all sorts of things, and then the return value is actually pushed through that proxy to your code. CDI works effectively the same way. The only difference is that CDI has fewer services. It's a newer technology. So why not allow CDI proxies to also benefit from these various things that we allow EJBs to do, such as security, asynchronous method invocations, and so on. So where CDI is significantly different than EJB in terms of how it's built underneath is the resolving of that instance is where the scopes come in. If your instance is annotated session scoped, it effectively looks in the HTTP session for the instance and then pulls it out and then does the invocation on that. If it's request scoped, it's effectively looking in a thread local for the instance, pulls it out, invokes it. And you can create custom scopes, which means that if you're an EJB fan, good news, you get to create your own bean type, which is pretty awesome. This is something that you can do with CDI, and the great thing is that if you simply want to manage the scope, when things live and when things die, you don't have to reinvent the entire wheel. All the dependency injection works, and all the other parts are there, and you simply have to manage resolving that instance. So this actual resolution part, there's an API in CDI for you to hook and implement that will basically allow you to say, here's the instance, use this one. Really good news for EJB fans. For those people who don't like EJB and were liking CDI, they might be disappointed to learn how similar they are. But we're talking to the choir here, so you guys are going to like that quite a bit. So here's how CDI and EJB line up. @singleton is effectively application scoped in CDI. They're really the same. Stateful is effectively any CDI scope. Stateful basically means that it lives as long as the user wants it to live. So in EJB, you have remove methods, and the stateful session bean is created when you reference it the first time, and then it's removed when you call the remove method. Well, basically, now if you want the CDI container to handle that creating and removing, creation and destroying, you annotate your stateful session bean with a scope, request scoped, session scoped, and then now it will be tracked by the container, and you don't have to manage it being tracked anymore. Stateless, there's no real equivalent because stateless is actually pooled. It's poorly named, and there's no pooling kind of concept in CDI, although, as I mentioned, the scopes are extendable standardly, so you could actually write pooling code if you wanted to have pooled beans. And you could write your own pooled scoped. It's sort of like request scope, but not quite, because with stateless session beans, you only get the instance for the duration of the method invocation, and it goes back into the pool. So what alignment means at the high level is allowing CDI beans to use these various things that we've created for EJB over the course of years. It is goals to kind of catch them up to each other in terms of functionality, so you can take advantage of things like extendable scopes and things like that, and not lose the EJB functionality that you're used to. And effectively will deprecate EJB in some regards, in a lot of regards, to be quite honest. But it will take a very long time. So I wouldn't expect EJB to go away anytime soon. But if you're an EJB fan, definitely look at CDI because you will be very happy with what you find. Okay, so one of the things that we were able to get done in JavaEE 7 is transaction attribute in the application exception annotations effectively now are replaced by the transactional annotation that was added in JavaEE 7. So here's how your bean might have looked using both those technologies with EJB. You have @transaction attribute mandatory, and if you wanted to have an exception that did not cause the rollback of the transaction, you would have to annotate it with application exception. The problem with this is that if you wanted to say runtime exception does not cause the rollback of this transaction, you had no way of doing that because that was not an exception class you created. You could not annotate it. You would have to go to the deployment descriptor and mark that exception as something that doesn't cause a transaction rollback, but then it would affect all of your usage throughout your entire server. And saying that runtime exception does not cause rollback is not wise. Very, very, very big recipe for disaster. So the new transaction annotation API allows you to say, don't roll back transactions on this exception and have that be just for that one method. So if you wanted to say wrap your entity manager usage and say if they throw this particular exception, it doesn't call, like say persistence exception, does not cause transaction rollback. I'll handle that later. Don't worry about it. So this is a better API, and we consider this to be a success of aligning CDI and EJB, but it came at a little bit of a cost. So the cost is that, the pro is that the API is better. It's a better API, definitely. And it doesn't say EJB in it, so it doesn't have JavaX EJB. There's a lot of people that don't like just the acronym EJB, and so they won't use the technology if it has an acronym anywhere near it. Sort of like getting kids to eat broccoli, It's good for them, and they probably like it if they tried it, but, ew, broccoli. Yeah, so EJB doesn't have cooties, but apparently a lot of people think it does. But what this did, though, is it duplicated this functionality, so now people who are new to the platform kind of get a bit confused. So what happens if someone does this out of just not knowing? What is supposed to happen? Are we going to start a transaction, or are we going to throw an exception? So if we go down this route of duplicating all the annotations so that they can be used in CDI, there is going to be somewhat of a cost. And so I think we're going to need to be a little bit careful about that going forward. But here are some of the things that I can try and whip through these real quickly that are things that EJB do which may or may not be ported to CDI. So right now, security is not under discussion. I think it's a Pandora's box and no one wants to mention it. They're afraid that if they start to say, let's move security concept over to EJB, everyone will want to rewrite the API like happened with @transactional. @transactional is slightly different than transaction attribute. I think it'll be very difficult for us to just move the existing security concept that really almost few people use over to CDI without being really compelled to change it. So I don't know, it might be good to wait before we do that one, because we do need a better security API than what we have. All right, @asynchronous is a high candidate for porting over to CDI. That's already tracked in Jira, has a lot of votes, and it's going to be very easy to add. I expect with 99% certainty that will happen in the next version of EJB and CDI. @schedule, very high chance of that one, although here is the interesting thing where EJB is in its mindset, is EJB goes, well, stateful session beans really shouldn't have timers because the beans only exist when users create them. Should we create a bean every time the timer exists and then destroy it? Well, that doesn't seem to work. Use a stateless bean like a singleton or a stateless bean, and that makes much more sense. When we have this discussion in context to CDI, we'll have to figure out what that means in terms of if you annotate something with like session scoped and you have a timer on it, are we supposed to be able to support that somehow? It's a little bit unintuitive. Locking. This one would be very easy to do. EJB in 3.1, we added @lock, which is available for singleton only, interestingly enough, not available to stateless and stateful beans, but it does make a lot of sense to put that on CDI as well if people wanted to have these types of locking mechanisms happen when they do these method invocations on the proxies. The container could do all the synchronization for you underneath, and that would actually be very useful. So that one would be very, very high. This one is a little tricky because having MDBs be part of CDI Beans, that would require quite a bit of reworking because basically not even singleton, stateless, and stateful beans can be MDBs. MDB is like a totally different bean type. But I can see it making sense, and I really hope that we really change the connector architecture a lot and that this could actually work. But I think it's a bit of a Pandora's box. I think there's a lot of people who, now that we've sort of revitalized the connector architecture a bit, people are looking at it with fresh eyes. They haven't really paid attention to it for 10 years. It's been collecting dust. So I think it'll take a while for everyone to figure out what the new version should look like. So that'll be a bit tricky. But that is the end of the presentation, but you should take a picture of this slide so you know where to go to get involved, because everybody here should get involved in the EJB specification. If you use the technology to any serious degree, it's in your best interest to become active. So any questions? I'm totally out of time, but I'm sure we can fit a couple in. No? All right. Thank you very much.